On this edition of SciTech Now, down by the creek, it's where Central New York students are getting a feel for Syracuse's urban waterway.
They're out there actually collecting and observing data and observations about the creek, and they start to understand it, and they start to realize that they've been places and done things that their teachers haven't, and it gives them a new feeling of ownership.
Then learn about a potential source of energy so powerful you can't see it, and go deep inside a botanical garden that has millions of species of plants, and they're all dead. Coming up next on SciTech Now.
SciTech Now is made possible through the support of our members.
Mohawk Valley Community College. Your future starts here, offering education and workforce development ranging from hands-on to high-tech, including nano, manufacturing, electrical engineering, and more. More information at mvcc.edu.
And by Giotto Enterprises, whose companies include Fiber Instrument Sales, The Light Connection, Molding Solutions, and Firmer Precision, providing solutions for fiber optic, telecom, molding, and CNC machining industries. More information at giottoenterprises.com.
Hello, I'm Simon Perez, and welcome to SciTech Now, our weekly program bringing you the latest breakthroughs in science, technology, and innovation here in Central New York and across the country. We begin at Syracuse's urban waterway, where 70 students watch science come to life as part of the Honeywell Summer Science Week at the Most. We join the students down by the creek to see what they learned about Onondaga Lake's watershed.
You guys what we found in this bucket so far?
It started about 20 years ago. I used to take college freshmen out to study the watershed. And 10 years ago, Honeywell came to the Most and said, what would you do with some funding for the community? And I said, let's take 8th graders out.
It was on Russian ship.
It's a left-handed wheel.
The focus of the Most is to impact middle school students. And so the Onondaga watershed is full of great places to take students to see the natural world. Today they're doing all aspects of creek ecology. So we're looking at soils, they're looking at the water chemistry, they're looking at macroinvertebrates in the water, they're looking at insects, they're looking at birds, they're looking at trees, and the environment around the creek. And so they've been looking at the gradients, what's changing. So one thing that changes is the temperature. As it gets into the city, it warms up. You have less trees over the creek. The creek is channelized, you have less places for macroinvertebrates to live. And so they see all those changes as the creek goes from a freshwater environment all the way down to the city.
This is the macroinvertebrate section of Honeywell Summer Science Week. We'll be kick netting to see what kind of invertebrates we find in the water. But today we're not finding that much because we're really close to all these urban areas, and there's a lot of buildings and input from the sewer system actually. So it's really low in diversity for invertebrates. But when we were at Heiberg and Tully, we were finding crayfish, mayflies, caddisflies, stoneflies. So it's a rich diversity. So we're just showing everyone as you get towards the lake, as you get towards more people, it really affects the species that can survive in the water.
I did the science fair for 3 years in middle school, and then I went on to county. So I definitely had like a feel for it. But going into this was my choice because I wanted to really almost get like one-on-one time, and these are all students, so it's great to know that they're all here to like help the younger generation.
One of the goals of this program is to get kids out in the field, out of their environment. And a lot of these kids have never been off a sidewalk. And so here they are. The first thing we tell them to do in the morning, get your feet wet. You don't have to worry about it the rest of the day. So they're out there actually collecting and observing data and observations about the creek. And they start to understand it. And they start to realize that they've been places and done things that their teachers haven't. And it gives them a new feeling of ownership and a sense of how to learn. They're learning on their own. And it's a powerful way to make them interested or get them interested in science and technology.
There's so much. Like, we learned how to stream profile and test water, like the water quality and how it's getting worse as we get closer.
They don't really.
Oh, that's cool.
So
I was a part of the program back in 2012. Little 8th grader going into 9th grade. My mom kind of pushed into it at first, and I kind of started to enjoy it a bit more. I'm not exactly sure how she found the program. She just kind of told me one day that I was going to be going to day camp at the most, Honeywell. It was kind of weird for me because I was homeschooled at the time, so interacting with other kids was a little bit overwhelming at first, but I met people and I made a lot of friends that I still actually talk to today.
It's fantastic to see that growth. So yeah, we even hire some of our past students to be camp or science counselors. And one of them has even gone on to be the lead counselor. And all of those students have gone to college in STEM and have graduated and are looking at careers in STEM. So we know this program has real impact.
Fresh water or 1 liter bucket of salt water?
I'd known it was polluted, but I hadn't learned like why or how it had become that way. So I definitely thought that was interesting, and I actually learned like how they were trying to make it better just by trying to clean it out. They talked about dredging, trying to clean out the lake. So we actually got to see them dredging when we went out on the boat tour on the first day. So that was definitely pretty cool to see.
The creek still has a lot of pollutants in it, but some of them are natural. So they were at Tully Valley 2 days ago, where there are salt springs that adds a load of salt to the creek. It's natural, it comes out of the ground. But then also there's an area in Tully where the creek is getting an influx of silt, and it's called the mud boils. And the mud boils are really fired up right now. It's been a really wet spring, and the creek is probably carrying about 25 tons of silt a day into Onondaga Lake. It just settles on the bottom of Onondaga Lake, but it makes Onondaga Creek inhabitable to fish. Fish don't like to be in a creek that's totally silted.
He's like, no.
Well, they generally just taught you that science doesn't have to be in the lab. You can have science anywhere. You can have it out on the water. You can have it with animals. You can have it with plants. You can have it with so many different things. It's just, not sitting in the lab all day.
They're going into high school next year, and we want them to have confidence that they can do science. And so we believe that we are changing the way they think and act in their science classes with this program, that they're going to be successful. They're not going to give up. They're going to go forward and do really well in high school and then go on to college.
Students who participate in the program say they are more interested in pursuing a science or technology career. Black holes are back in the pop culture lexicon thanks to movies like Interstellar, but scientists have pondered them for decades. As SciTech Now's Hari Srinivasan tells us, some researchers believe one day black holes may be a source of energy for our planet.
A black hole crushes everything, and it just sort of is almost like a vacuum, and it sucks everything up. You're talking about energy coming from a black hole and us figuring out some way, theoretically, to grab that. How does that work?
That's right. So for many years, we thought exactly like you just said, that black holes are just like hoovers. They have an infinite gravitational potential. No matter how hard you fire your rocket, you're still just going to get sucked in, and you're going to hit the singularity, and you're going to die. And unfortunately, that's still true. You're still going to get sucked in. But Hawking discovered something in the 1970s that shocked everyone. So black holes were invented way back by Albert Einstein in 1915, a century ago. But in the 1970s, Stephen Hawking discovered that, in fact, energy can escape from black holes. Sure, you're going to get sucked in and you're going to get crushed to death, but eventually your energy will leak out. And that's due to quantum mechanics, this sort of shadowy little quantum fluctuations at the smallest scales allow energy to leak out of black holes in what's called Hawking radiation.
Hawking radiation. So how could we theoretically tap into Hawking radiation?
If we were content to wait a really long time, you could just hang around and eventually the black hole would disintegrate all on its own into Hawking radiation. It would just slowly sort of disgorge itself back into the universe. The catch is that that takes a really long time. So if you take a black hole that weighs, say, the mass of the sun, the same weight as the sun, it'll take a tremendously long time, 10 to the 57 times the current age of the universe, before it's given all its energy back into the back out. So say you were some hungry civilization long in the future, that would be a very, very long time to wait in order to get at the energy out of black holes. Scientists have looked for ways to try and get the energy out faster.
So haven't there been black holes, though, that have been disintegrating around the universe in different places that are probably now exhibiting some of that Hawking radiation?
Every black hole, we believe there is a black hole at the center of the galaxy, for example, and there are many black holes that result from supernova explosions. Every one of them is emitting Hawking radiation the whole time. The problem is that the Hawking radiation is very, very cold. It's only giving it out very gently indeed. So a black hole that weighs the mass of the sun is giving it out at 60 nanokelvins. And unfortunately, the universe is much hotter than 60 nanokelvins. So even though it's emitting a small amount of this Hawking radiation, much more energy is falling into the black hole than is being emitted in Hawking radiation.
When you talk about giant space elevators that can be built on sort of nanotubes, or what are some of the ideas that you grapple with and you say, well, that could actually work, no, that can't work?
Right, so there's this old idea for how you can speed it up, how you can take this normal, natural emission of the black hole and make it much, much faster in order to try to grab the energy much sooner than waiting around for 10 to the 57 times the current age of the universe. And that idea involves, it's actually quite simple. You take a box and you lower the box to really close to the black hole horizon, so really close to the point of no return. You obviously don't want to lower the box over the point of no return, otherwise the box will not return. But you get it very close to the point of no return, dangle it on a rope, pull really hard, and then drag out the box down to close to the black hole and then back out again.
So it's a bit like fishing.
Like a box on a string. And the idea of this is that Hawking also showed that if you get really close to the point of no return, there's a hot gas there, that in fact there's a lot of energy there, which you can just scoop up with your bucket, drag it out, and in that way rob the black hole of its radiation, and greatly, it is claimed, speed up the process of black hole disintegrations, greatly expedite extracting energy from the black hole.
If I understand this, it's almost like the black hole is a well and you're just sinking a bucket very close to the water and you're picking up some of this energy and you're bringing it back, but there's no rope that we could possibly build that's strong enough.
So this is an old proposal that you can do this. But actually, it turns out that there is a problem, and the problem is the strength of the rope. Scientists have a word for what this kind of device is, and it's called a space elevator. A space elevator is something that dangles down under tension and is able to support weight in that way. Usually, people talk about them in the context of building a space elevator around Earth. So this is an idea that goes back to Arthur C. Clarke, the science fiction writer, and before, and he imagined that you could dangle a rope from way out in geostationary orbit, where that end would be supported by its own centrifugal force, and you could dangle it down towards the surface of the Earth. And because it's being held up by this orbital motion at the top, it would just dangle there and be able to support itself. The problem with that, and then the idea is that you could then climb that rope and avoid having to use expensive and dangerous and smelly rockets, and just be able to get into space much more easily and effectively. This is an idea, and people do talk about doing this. It's extremely around Earth. This is building a space elevator around Earth. It's an extremely difficult proposal, and one of the great difficulties is knowing what to build the rope out of. The problem is that the rope is trying to tear itself apart under gravity. Gravity is tugging on one end of the rope, and so the rope needs to be very strong to resist the pull of gravity. On the other hand, it also needs to be very light in order that the pull of gravity is somewhat less. And so steel just won't work. Steel will tear itself apart in the Earth's gravitational field, but there is a material that won't tear itself apart in the Earth's gravitational field that is strong enough and light enough to make it work, and that's carbon nanotubes. So that's an idea that works on Earth. When people talk about carbon nanotubes, this futuristic material we've managed to make in the lab in small quantities, but maybe we could someday figure out how to make it on industrial quantities, we could build a space elevator around Earth, a rope that dangled all the way down to the surface of the Earth that would resist being pulled apart by gravity. Unfortunately, if you try to do the same thing around a black hole, it just doesn't work. Not with carbon nanotubes, it doesn't work. The gravitational field of a black hole is so much more intense that it'll pull itself apart. It's not just that carbon nanotubes won't work, it's that nothing works.
Theoretically, you have sealed our fate We will most likely run out of energy as a planet when the sun dies, and we can't mine black holes. Is that what you're telling me right now?
Unfortunately, we can't mine black holes.
All right, so I will leave you to that blackboard behind you, which has a language that I will never understand. I thank you very much, Adam Brown from Stanford University, for this moment of deep thought.
Okay, thank you. I'm sorry to be a bearer of bad news.
Scientists believe a black hole is at the center of almost every galaxy. The Milky Way's black hole is 4 million times larger than the Sun, but not to worry, scientists say it's dormant. Dead plants don't usually get people all that excited, but in this segment, we'll take you to a museum that has millions of them. Take a closer look at the scientific treasures housed at the New York Botanical Garden.
An herbarium is a collection of dried plants for scientific study. So plants have been collected for many, many years, going back to the Middle Ages. Starting out, they were collected mostly for medicinal purposes. We have about 7.3 million specimens, which makes us the 4th largest herbarium among the top 4 in the world. So now we're coming into our cold storage room. This is kept at about 54 degrees, and it's the holding space. When the plant specimens first arrive at the garden, they come in here, right from the field. On this side of the room, all of the specimens are our staff's field collections, and those are waiting to be identified. Sometimes it takes a few months for specimens to be identified. Sometimes it takes 50 years. It depends on whether or not that plant group has a specialist. On this side, all of these plants are already identified, and they're just waiting their turn to go up to the mounting room, where they'll be glued to paper and then eventually filed in the herbarium. So this is the specimen mounting room. All of the plants that come into the New York Botanical Garden each year from all of our many field expeditions eventually end up here. And this is the room where they're turned from field specimens into permanent archives that are meant to be kept indefinitely. What makes it a good specimen is if it shows all the features that are important to see. In the mounting room, we have several people highly skilled in taking these specimens from their newspaper, gluing them onto a piece of paper. We just use a basic Elmer's type of white glue. Sometimes the woody plants aren't completely flat, so they can use glue, but sometimes they also have to stitch down the plant. Sometimes the plant has bits that come off, which have to be put in a little packet, and they also try to make it look attractive as well. So now we're coming into the herbarium. This is the actual archive where the specimens are stored. This is a typical floor. It contains about 2,000 cabinets that are arranged on these movable aisles. The steel cabinets that we have in the herbarium are all specially designed for this purpose. In fact, this is even called the New York Botanical Style herbarium cabinet. Each cabinet has 52 shelves. The plant specimens are put in paper cardboard folders. They're arranged by plant relationships, by their family. Every plant belongs to a family. And they then are also arranged in these outer folders, which are color-coded. Here's a specimen that was collected fairly recently, actually 2001, from the Intermountain West, where we've been focusing a lot of our collecting activity for the past 50 years. Here's a specimen that was collected by Charles Darwin. We don't think of Darwin much as a botanical collector, and in this case, the specimen is actually not even a flowering plant. It's a tiny moss that he collected on the voyage of the Beagle. We also have specimens like Darwin that are very old. Here's one that's even older. Here's a specimen from the Captain Cook voyage, which went around the Cape of Good Hope and Cape Horn in the 1700s. This is a specimen collected from Tierra del Fuego. We also, since the mid-90s, have been creating a virtual herbarium. We've been digitizing the specimens and making them available online so that anyone at any time can consult the herbarium just by coming to our virtual herbarium website and searching. We would just capture an image using a high quality but an instant capture image, and then when we put them online, instead of writing a request wondering what specimens do you have of this plant or that plant, they could simply go online and look and find out. One of the things I really enjoy is taking a walk through the herbarium every day. And as I walk around, I see my staff who are working on projects. I like to walk around and just see science in action.
You can explore the Steer Herbarium virtually, as many of its specimens are available online. Go to our website for the link. With so many Americans expected to suffer from Alzheimer's disease in the coming decades, research into how the brain works seems more important than ever. Scientists at Columbia University have had some success figuring out the mysteries of the mind.
The brain is the most magical and complex structure in the universe. It makes us who we are. And every mental process, from hitting a backhand to tennis to writing a Beethoven symphony, comes from the brain.
Neuroscientist Dr. Eric Kandel arrived at Columbia in 1974.
When I came along, there were a number of views that learning occurs through electric fields outside of nerve cells. We now have a much more specific idea of how learning occurs. It involves changes in the strength of how nerve cells communicate with each other.
Awarded the Nobel Prize in 2000 for his work on age-related memory loss, Dr. Kandel is part of a long-standing legacy of outstanding science at Columbia.
This is the enormous challenge that confronts us. This is what makes us truly human, and we all want to understand it. We not only want to understand it because we want to understand how we function, but when you think of the diseases that haunt mankind, Parkinson's disease, Huntington's disease, Alzheimer's disease, we want to understand it so we can develop better treatments.
In this plane, you can see how the basal dendrites really radiate out. It's really cool.
His colleagues include Dr. Randy Bruno. Dr. Bruno and his team at Columbia University Medical Center recently made a groundbreaking discovery about the cerebral cortex.
The cerebral cortex is the outer couple of millimeters of your brain, and it's the part that we're pretty certain you do all the smart stuff that you do in your day. You know, you're looking at me, you're processing my voice, you're planning where you're going to go next during the day. What we discovered is that the cerebral cortex actually has two halves. It's almost as if there are two cortices there that we're actually using, we think, for very different tasks, for very different behaviors, for very different functions. And it might be that certain pathways in the brain from one of these systems that we've identified to other parts of the brain is actually the root problem in a particular disease. And the other part isn't. And that might give us some means for focusing down onto exactly what types of cells, what types of synaptic connections, which proteins, which genes are actually at the root of the problem in a particular disorder.
To make these discoveries, Dr. Bruno relies heavily on developments in technology, high-tech microscopes such as those being built by another colleague, biomedical engineer Dr. Elizabeth Hillman at the Fu Foundation School of Engineering and Applied Science.
Studying the brain is really, really challenging because you want to have it intact and working while you're trying to observe it, which means we just are constantly looking for new tools.
Dr. Hillman is currently working on 3D imaging that enables researchers, like Dr. Bruno, to better study how brain signals move from one neuron to the next. It's the type of technology that may someday also help behavioral psychologist Dr. Sarah Woolley, who studies songbirds, with the hope that her work will one day help crack the code to diseases like autism.
Autism often features developmental delays in language acquisition, and if we could roll back time essentially and reopen critical periods for vocal learning in the songbird, then we can try to figure out what are the internal biochemical and circuit level cues that allow an animal who has a delay in learning vocalizations to be able to do it.
All of these neuroscientists are working together as part of Columbia's Mortimer B. Zuckerman Mind-Brain Behavior Institute, dedicated to the study of the brain.
This marriage, this unification gave rise to a new science of mind, which allows us to explore in great detail all the great questions that relate to mind and brain. How we think, how we feel, how we experience, how we remember things. All of these things are now being approached in a unified way. Molecular biology is a driving force within it, but it's one component of a much larger picture.
One of the more recent discoveries by Columbia researchers shows your attitude can play a role in how well your brain functions. Parkinson's patients who were given placebo pills showed just as much improvement in their brain function as patients who were given medicine, which means just their expectation of receiving a drug helped them even though they didn't get it. That's it for this edition of SciTech Now. For more information on science, technology, and innovation, visit our website at wcny.org/SciTechNow. And you can join the conversation on Facebook and Twitter. Next week on SciTech Now, using your phone to take care of yard work. It's an idea developed by two local entrepreneurs. Then find out where solar power might actually work better than fossil fuels. And meet the misfits of our planet, animals whose behavior doesn't quite make sense. I'm Simon Perez. We'll see you next week on SciTech Now.
SciTech Now is made possible through the support of our members.
Mohawk Valley Community College. Your future starts here, offering education and workforce development ranging from hands-on to high-tech, including nano, manufacturing, electrical engineering, and more. More information at mvcc.edu.
And by Giotto Enterprises, whose companies include Fiber Instrument Sales, The Light Connection, Molding Solutions, and Firmer Precision, providing solutions for fiber optic, telecom, molding, and CNC machining industries. More information at giottoenterprises.com.